Alright, so here we see a pendulum with a particular length. We have a mass at the end, and we do see the fact that it completes a period of 1.59 seconds. We want to see how long does it take for the mass to fall a distance of 1 meter if the string is cut. Remember, if you watched the example before, that I said that we can't always assume that our pendulum is on Earth. So we're going to go ahead and look at the fact that since we're given period, we're given the length and that kind of thing, we are then able to find, well, what is our local gravity? Because this is actually how scientists find the local gravity in an area. So we're going to look at that equation. Okay, so like I said before, our period is equal to 2 pi times the square root of L over G. When we rearrange this equation like I've done here, we can see the fact that G is equal to all that. I will tell you, you will need to know how to do that algebra on your own, because you will not be given that equation solved for G. You do need to be able to rearrange the equation on your own. From here, all this information is sort of set up for us so that we can find out what is the gravity for this particular pendulum, given the information we have in our problem. So I'm going to go ahead and plug and chug that. Alright, so if we entered everything into our calculator properly, after we look at how that equation is laid out, we do get the fact that gravity in this particular case is 9.79 meters per second squared. So very, very close to what we actually treat gravity as, is that 9.8. So now we have gravity, and why did we go through this whole process? Well, we're trying to look at how far does how long does it take our object to fall 1 meter. Well, this actually means that we need to go all the way back to chapter 3 stuff and chapter 4 stuff for objects in free fall. So we're going to go ahead and pull those kinematic equations. We know that our object is starting at rest. We know the change in position our object is going to go, and we know the fact that it's in free fall means that there is acceleration. As a result, that does tell us we need to pull the first kinematic equation. So here we have our first kinematic equation. So we are looking at the fact that our object is going to fall 1 meter, so that xf is going to be 1. We can go ahead and assume that xi is 0, just to make our lives easier. Vi, we know, since it's dropped, because it's initially held at rest, is going to be 0 as well. So it goes ahead and simplifies our equation very significantly, so that we just have the xf is equal to 1/2 at squared. So from here we are going to take that equation and solve for t, right? And I'll show you what that looks like. All right, so this is the equation that solved for the variable that we wanted, again, t. So t is equal to that square root of 2 times my xf divided by a. Remember, g is a very specific type of acceleration, and it is the acceleration due to gravity. So we have g, we have the distance that our object wants to fall, so we are then able to plug all of our information in. Alright, so we plugged all of our information in, and then we are able to plug that into our calculator. Alright, and as a result, we do get the fact that it takes about less than half a second for our pendulum to drop.